Okay, so now we're ready to tackle not necessarily harder, but a little bit more difficult probability problems, and those involve compound events. So a compound event is combining two or more simple events. So again, tossing a coin twice would be a compound event because you're doing it, there's two different simple events there. You might toss a coin 50 times, that is still a compound event. So we will define disjoint or mutually exclusive if two events cannot occur at the same time. If two events cannot occur at the same time. So let's say my procedure is to, let's say, roll a die once. Just one time, right? And if I say event A is, if A is getting a 6, oops, that's a terrible 6, getting a 6, and event B is getting a 3, can these things happen at the same time? No, they can't. So these would be called disjoint or mutually exclusive. Okay, so how we calculate those probabilities. If two events are disjoint or mutually exclusive, then you calculate their probabilities by just taking what the probability of A would be and adding it to the probability of B. So here we would find the probability of getting a 6 and probability of getting a 3, and then we would add those together. So if I have 6 colored dice in a bag, 3 red, 2 green, 1 blue, I think I can simulate this. Alright, so here's my bag with my different dice in it, right? And there are 3 red, 2 green, and 1 blue. And it says find the probability of getting a green or a blue. So these can't occur at the same time. I can't pick out a die and it be green and blue at the same time. So these are mutually exclusive or disjoint events. The probability of getting a green, well, take a look. There are 2 of those out of 6 total die. So the probability is 2 out of 6. I won't simplify the fraction here yet. I'm going to wait because you know I'm going to do something which is to add these two probabilities together. The probability of getting a blue, there's 1 out of 6 of those. So since this says or, this lets us know we need to add 2 out of 6 plus 1 out of 6. You may not like adding fractions, but I'll tell you with probability, a lot of times you will have common denominators. So you see the same number on the bottom, means that number stays, and then the numbers on top, let's add them, 2 plus 1 is 3 out of 6. Again, you can use a calculator for that if you're not comfortable with fractions, but I think we can handle these ones. They're not too terrible. So the probability of getting a green or a blue is 3 out of 6 or 1/2, and you can kind of see in this situation, there are 3 out of 6. The next one is rolling a 6-sided die, so here's the possible outcomes. Whoops, 4, 5, or a 6. So here is my sample space for that. And we want to find the probability of getting a 5 or a 6. Just like in the last example up here where I described what disjoint or mutually exclusive is, I can't get this at the same time. So the probability of getting a 5 is 1 out of 6. The probability of getting a 6 is also 1 out of 6. The OR tells me to add these two together, so I get 2 out of 6, which we would reduce to 1/3. Okay, in the next video, we're going to take a look at events that are not disjoint. So just a quick intro is events that are disjoint can't happen at the same time, right? But what happens if I roll a die, I want to find the probability of getting an even or a 2. So you can see if I look for the evens and the 2s, there's going to be some overlap. This event would be not disjoint, and the way that we approach this probability is slightly different. It's got a little nuance to it, so slightly different than what we did in the previous problem. So check out the next video where we go further into this.